Imagine a world where objects can be in two places at once. This isn't science fiction. This is the bizarre, mind-bending reality of quantum physics. It's a field that defies our everyday experiences and challenges our understanding of the universe. Quantum physics governs the realm of atoms and the tiny particles within them. These particles behave in ways that are completely different from the objects we see around us. It's a world where the rules of our everyday experience break down, replaced by something far stranger and more wonderful. Scientists often find themselves puzzled by the results of their experiments, which can seem to defy logic. In our macroscopic world, we take for granted that objects have definite properties. A chair is solid, a ball is round, and these properties don't change depending on how we look at them. A ball is either red or blue, moving or stationary. We can predict its behavior with certainty. Yet, in the quantum realm, particles can exist in multiple states simultaneously. This means a particle can be in two places at once or spin in two directions at the same time. They can be both here and there, spinning up and down all at the same time. This phenomenon is known as superposition. This concept, known as superposition, is just one of the many counterintuitive ideas that quantum physics throws our way. It forces us to rethink what we know about reality. It challenges our fundamental understanding of reality, suggesting a universe far more complex and mysterious than we ever imagined. Quantum physics opens up a world of possibilities where the impossible becomes possible, and the boundaries of our knowledge are constantly being pushed. The implications of quantum physics are vast, influencing fields like computing, cryptography, and even our understanding of the cosmos. Quantum computers, for instance, have the potential to solve problems that are currently unsolvable by classical computers. Another fascinating phenomenon is quantum entanglement, where particles become interconnected in such a way that the state of one instantly influences the state of another, no matter the distance between them. This interconnectedness hints at a deeper underlying reality that we are only beginning to understand. The study of quantum physics is not just about understanding the very small, it's about uncovering the fundamental principles that govern the entire universe. As we continue to explore this strange and wonderful world, we may find answers to some of the biggest questions in science. What is the nature of reality? How does the universe work at its most fundamental level? The journey into the quantum realm is just beginning, and it promises to be one of the most exciting and transformative scientific adventures of our time. The more we learn, the more we realize how much there is still to discover. So, as we delve deeper into the surprising world of quantum physics, we are not just expanding our knowledge, we are expanding our imagination and our sense of wonder about the universe we inhabit. Quantum physics might seem like an esoteric subject confined to the depths of research labs. However, its impact on our daily lives is profound and far-reaching. From the lasers that read our Blu-rays to the transistors that power our smartphones, quantum physics underpins many of the technologies we rely on. Without an understanding of how atoms behave at the quantum level, we wouldn't have lasers, computers, or even modern medicine. Medical imaging techniques like MRI and PET scans, which allow us to peer inside the human body without invasive procedures, are direct applications of quantum principles. Moreover, quantum physics is driving the development of future technologies. Quantum computers, still in their infancy, promise to revolutionize fields like medicine, materials science, and artificial intelligence. These powerful machines leverage the strangeness of the quantum world to perform calculations that are impossible for even the most advanced classical computers. Quantum physics is notoriously difficult to grasp. It's a field that has puzzled and fascinated scientists for over a century. The concepts and principles that govern the quantum world are so counterintuitive that they often seem to defy common sense. Our intuition, honed by our experiences in the macroscopic world, often leads us astray when we try to make sense of the quantum realm. In our everyday lives, we are used to objects having definite positions and predictable behaviors. But in the quantum world, particles can exist in multiple states at once, and their properties can be fundamentally uncertain. The rules that govern the behavior of atoms and subatomic particles are unlike anything we encounter in our everyday lives. At this scale, particles can tunnel through barriers, become entangled with one another, and exhibit behaviors that seem to violate the laws of classical physics. One of the biggest challenges is the probabilistic nature of quantum mechanics. Unlike classical physics, which deals with certainties and exact measurements, Quantum mechanics operates on probabilities. This means that we can only predict the likelihood of finding a particle in a particular state or location, not its exact position or momentum. Unlike classical physics, where we can predict the exact trajectory of a ball thrown through the air, quantum mechanics only allows us to calculate the probability of finding a particle in a particular location. This probabilistic nature is encapsulated in the famous Schrödinger equation, which describes how the quantum state of a system changes over time. This inherent uncertainty is a fundamental aspect of the quantum world. The Heisenberg uncertainty principle states that we cannot simultaneously know both the exact position and momentum of a particle. The more precisely we know one, the less precisely we can know the other. This principle is not a limitation of our measurement tools, but a fundamental property of nature. Another mind-bending concept is wave-particle duality, which states that particles like electrons can exhibit both wave-like and particle-like behavior. This duality was first demonstrated in the famous double-slit experiment, where electrons create an interference pattern, a hallmark of wave behavior, even when fired one at a time. This duality challenges our classical notions of what it means to be a wave or a particle, blurring the lines between these seemingly distinct categories. It suggests that the true nature of particles is more complex and nuanced than our everyday experiences would lead us to believe. Understanding these concepts is crucial for advancing our knowledge of the universe and developing new technologies that harness the power of quantum mechanics. Section 4. Quantum superposition. Embracing the power of both and. One of the most intriguing concepts in quantum physics is superposition. This principle challenges our classical understanding of reality and opens up a world of possibilities that seem almost magical. Imagine a coin spinning in the air, not yet landed. In this moment, it holds the potential to be either heads or tails. In our everyday world, we know it will eventually land on either heads or tails. This binary outcome is what we are accustomed to. But in the quantum realm, a particle can exist in a superposition of states, meaning it's in both states simultaneously until measured. This defies our everyday experiences and stretches our imagination. Think of it like a musical chord. When a musician plays a chord, they are playing multiple notes at the same time. A chord is made up of multiple notes played together, creating a harmonious sound that is richer and more complex than a single note. Similarly, a quantum particle in superposition is in a combination of multiple states at once. It's as if the particle is playing all possible notes simultaneously. It's not that the particle is switching rapidly between states, it's truly in all states, simultaneously. This is a fundamental aspect of quantum mechanics that sets it apart from classical physics. This concept has profound implications. It suggests that the nature of reality at the quantum level is far more complex and interconnected than we can perceive with our senses. It means that at the quantum level, the act of measurement fundamentally alters the state of a system. The observer and the observed are intrinsically linked. Before measurement, the particle exists in a blurry haze of possibilities. This haze represents all the potential states the particle could be in. Only upon measurement does it collapse into a definite state. This collapse is a pivotal moment where potential becomes reality and the abstract becomes concrete. To illustrate this further, consider Schrödinger's cat, a famous thought experiment. The cat in the box is both alive and dead until someone opens the box and observes it. This paradox highlights the strange and counterintuitive nature of quantum mechanics. It forces us to rethink our understanding of existence and observation. Another fascinating aspect is quantum entanglement, where particles become interconnected in such a way that the state of one instantly influences the state of another, no matter the distance between them. These principles are not just theoretical, they have practical applications. Quantum computing, for instance, leverages superposition and entanglement to perform computations far beyond the capabilities of classical computers. Quantum algorithms can solve complex problems in seconds that would take classical computers millions of years. This technology has the potential to revolutionize fields such as cryptography, medicine, and artificial intelligence. As we continue to explore and understand the quantum world, we are likely to uncover even more astonishing phenomena. The journey into the quantum realm is just beginning, and it promises to reshape our understanding of the universe. Embracing the power of both and in quantum mechanics invites us to see the world not in black and white, but in a spectrum of possibilities. It challenges us to expand our minds and embrace the complexity and beauty of the universe. The quantum world is a testament to the boundless potential of human curiosity and the endless wonders that await us when we dare to look beyond the surface. Section 5. Quantum Entanglement, the curious case of spooky action at a distance. Albert Einstein famously called it spooky action at a distance. Quantum entanglement is one of the most bizarre and counterintuitive phenomena in physics. It occurs when two particles become linked, even when separated by vast distances. Imagine two coins flipped simultaneously, one landing on heads, the other on tails. In our everyday world, this is just a random event. But in the quantum world, two entangled particles can be linked such that if one is measured to be in a particular state, the other instantly knows and adopts the opposite state, no matter how far apart they are. This instantaneous correlation has been experimentally verified time and again, defying our classical understanding of causality and locality. It suggests that there's a deeper level of interconnectedness in the universe than we previously imagined.